Okay, give ourselves a little bit of space here. So this is day 2 of the, oh crap, what were we doing? Oh, number types and properties, okay? So day 2 of number types and properties. So let me scroll in here so we can read the problem. All right, so it says, at an ice cream shop, the profit, represented by the function P of C, is modeled by the function the profit, which is, this is considered your output, okay? Another fancy name for output is your dependent variable. And more plainly, your output is also called your y values, okay? So that's what that represents. Whoops. And your output, dependent variable, y values, okay? So this function was modeled by this right here. Right? So your function P of C is equal to 0.87 times C, where C represents the number of ice cream cones sold. So C is your input, okay, or your x values, or more importantly, your independent variables, okay? So let's think about it like this. Your profit is dependent, okay, so your profit, right, is dependent on how many ice cream cones you sell. Right, so if you sell 0 cones, you make $0. So that's why it's called the independent variable, because that's why C is your independent variable, because it determines, all right, it's kind of its own thing, all right? Your profit is dependent on how many cones you sell. So your cones are your independent variable. That being said, right, we're looking for an appropriate domain, okay? So we're looking for we're doing number types and properties, okay? So in this case, we're looking at either rational numbers or integers, all right? So don't worry about the inequality right now. Let's just talk about what a rational number and an integer is again. Okay? So let's talk about the integers first. All right, so it's pretty much all your whole numbers ranging from negative infinity to infinity. Okay? So there's no decimals, all right? They're all whole numbers, but they range from negative infinity to infinity. Okay, so they go on forever. Your rational numbers, right? Don't forget rational is fractional, okay? So they can be represented as fractions. They can be non-terminating. Whoops. They can be non-terminating, but they either repeat or have some sort of pattern. Okay, so you can have 0.555, repeating 5s, or 0.121212, okay, where 1 and 2 are being repeated. All right, and then you can also have whole numbers as well, okay, but in those cases they're just put over 1. So you could take 2, put over 1, now we have a fraction. Okay, so integers can be represented. Integers are rational numbers, okay, because they can be represented as fractions. All right, but typically we don't write them like that if we don't have to. Okay, so that's the difference between both of those. So let's take a look at what our input represents here. All right, so our input is the number of ice cream cones sold. Okay, so I know you guys love getting technical with these things, and you start saying, well, you can sell part of an ice cream cone. No. All right, if I'm at an ice cream cone shop and someone hands me a cone that I just purchased, I want the whole cone. I don't want a bite taken out of it, okay? So when we're buying ice cream cones, we're talking about buying a whole cone, okay? So we don't want to use rational numbers, okay, because we don't want fractions of a cone. So then we got to look at whether it's this one or this one. Okay, so this one here represents an integer that is less than or equal to 0, which means, let me just throw a number that's less than or equal to 0, -1. Okay, or -5. Are we selling, I mean, would you make any money? Sounds like somebody's eating the cones, all right? So we want negative numbers for an integer. So we want positive integers. You're wondering, greater than or equal to 0, is that allowed? Yes, because we can still sell 0 coins. We can potentially just not open for sale that day and make no money. All right, that being said, that is the answer for number 6. Okay, we scroll down to number 7. So it says, is the product of the square root of 6 and 4/7 rational or irrational? Okay. So first I want to look at the square root of 16. If I said square root of 6, I'm sorry. Square root of 16. All right, there's something significant about that number. And if you're wondering why I'm writing these numbers off to the side, it's because these are our perfect squares, okay? 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, okay? Those are our perfect squares. All right, so as you can see, all right, 16 falls in one of those perfect squares. So when you take the square root of 16, right, what you're really doing is you're you're taking the square root, right? What times what equals 16? In this case, 4 does. All right, so now we're left with just 4. Draw a better arrow. Okay. There we go. 4 times, okay, and it says the product, right? So if you're wondering why I'm using 4 times, okay, it's because it's the product. So when we're talking about the product of two numbers, we're talking about multiplication. Okay, so it's going to be 4 times 4/7. Right? And 4 could be represented as a fraction, like we were just saying in the problem above. And when you multiply with fractions, we just multiply straight across, which is kind of nice. We don't have to worry about common denominators. So 4 times 4 is 16, and 7 times 1 is 7. So our answer is 16/7. Now what we just talked about above is we said that if it can be written as a fraction, it is rational. And because this is written as a fraction, this is a rational number. Okay, and the rule is anytime you multiply a rational times another rational, you will always get a rational number. In this case, square root of 16 was a rational number, and also 4/7 is a rational number. And so therefore, rational times a rational equals a rational. Okay. On to number 7. Or I'm sorry, number 8. That was number 7. Number 8. John was given the equation 4 times in parentheses 2a plus 3 is equal to -3 times in parentheses a minus 1 plus 31 minus 11a to solve. Whew. Okay. Let me get the rest of the problem in here so I can read it. Some of the steps of the reasons have already been completed. State a property of numbers for each missing reason. Okay, so what we're going to be doing here is we're going to be watching as John solves this equation. And they've already filled in a couple of these steps, and we're going to fill in the other 2. So it says some of the steps have already been completed. Our job is to state the properties for the missing reasons. Okay? So if we take a look at this one, this is our given. All right, and take a look at this one right here. And what is different? Looks like there's something different on both sides. They did some property in order to simplify the expression, or the expression on both sides of the equal sign. Okay, in this case they use the distributive property. Okay, the distributive property. They distributed the 4, into the parentheses here, and they distributed the negative 3 in the parentheses there. So it's the distributive property. Okay, the next one, they just combined like terms. Okay, so nothing on the left here, but on the right, they combined the 3 and the 31 and the 2 A's. Okay, so that is combining like terms. That's what they did for that step. And then I want you to take a look at this one right here and this one right here. And what is different? Okay, if we notice, we don't have the negative 14a over here. And 8a then became 22a. So what it looks like is they added 14 to both sides. So what happens here is when you add 14a to both sides. When you add 14a to both sides, these cancel over here, and this becomes 22a. So what they did was they added 14a to both sides, so they used the addition property of equality, okay, or the APOE. Do not abbreviate that for your guys' regions, okay? Make sure you write that whole thing out. I know sometimes I do that as I'm solving these problems. I don't mind when you put that in your homework, but let's start getting in the habits of, good test taking habits here. So make sure when you write that property, you got to write the whole thing. The addition property of equality, okay? Or the APOE for short. Okay. Let's take a look at number 9. State whether the product of square root 3 and square root 9 is rational or irrational, and explain your answer. Okay, so first, whether the product. So we're talking about product here. Okay, what we're talking about is multiplication. So they want us to multiply these two numbers. So state whether the product of square root 3 and square root 9 is rational or irrational. Okay. Now, let's take a look at these numbers here. So let's take a look at square root of 3 first. Now, square root of 3 is not one of our perfect squares. Okay, 36, 49, 64, so on and so forth. Okay, so what that means is when you take the square root of 3, you're going to get an irrational number. All right, and if you did that in your calculator right now, if you plugged it in, you would get something nasty. So I want everybody to do that. The square root of 3. Get square root of 3, math bracket, and it'll stay the same. Okay, so that lets you know that this number, square root of 3, is irrational. Okay? All right, it doesn't change. Now, let's look at the square root of 9. Okay, square root of 9 is one of our perfect squares. It actually is 3 times 3. So that's what it means to square root. Right? What times what equals 9. So when you take the square root of 9, you get 3, right? Which is a rational number. But what happens here is when you multiply an irrational by a rational number, you get an irrational number. Okay, so you're going to get 3 times the square root of 3. All right, and if you plug that into your calculator, whoops. Okay, you should get 5.196152423. Right? Should keep going. Your calculator just runs out of space, and then if you math frac that, it stays the same. Okay? So that's a little trick you can use when you get these big, long, nasty decimals. If you want to try to figure out whether or not this is a rational number, if you math frac it and it goes back into a fraction, you know you're good to go. Okay, in this case, 5.196152423 stays the same. Okay, and also you can kind of look, we see a pattern. No, nothing's being repeated. Okay, and this number should go on forever. All right, so therefore, the product of square root 3 and square root 9 is irrational. Okay. Number 10, and then we'll be done with this video. And hopefully you guys are checking your work. Okay, don't be just listening to me talk and filling in the answers. Make sure you guys are doing this before, or at least attempting it before you start watching the video, or, you know, getting the answer keys. Okay? It's important that you guys are trying these problems on your own. Because I can do these problems. It's important you guys know how to do them. Okay, so a part of Jennifer's work to solve the equation 2 times, in parentheses, 6x squared minus 3 is equal to 11x squared minus x is shown below. Given this one here and this step here, right, which property justifies her first step? Okay, so a little lengthy on the wordies here. Identity property of multiplication, multiplication property of equality, commutative property of equality. Right, let's just take a look at, before we start reading all those and scaring ourselves here, let's just take a look at what happened between the given and step 1. All right, so take a look. What looks different between the given and step 1? Well, over here on the right, everything stayed the same. We're looking over here on the left. Okay, and what it looks like is they took that 2 and they multiplied it across that expression. And what property involves multiplying a number outside of the parentheses across that binomial? Because that's a binomial in there, right? It's distributive, right? We distributed that 2 across this expression here. So 2 times 6x squared is 12x, and 2 times negative 3 is negative 6. Okay? And so that's the answer for the number types and properties, Algebra 1, numbers 6 through 10. Okay? Keep following along. Enjoy your day, guys. All right, stay safe out there. It's kind of nice today. Today's Friday, so make sure you're getting a little bit of sunshine. I know it's important to stay kind of away from everybody, but make sure you guys are still getting outdoors and getting that fresh air. It's important. Don't forget to do your math homework.